Hello students, once again welcome you all in my YouTube channel B.Sc Chemistry classes. Today we are going to study the important Debye-Huckel Onsager equation. So this is very important equation for all the classes students who are studying the electrochemistry. This equation is given by our Debye-Huckel and later on it is modified by the Onsager. So the simple form of this equation is our lambda V is equals to lambda infinity minus A plus B lambda infinity into square root of c. That is the, so what are these terms? So this is, if it is asked in the 2-mark question, what is Debye-Huckel Onsager equation, you can give this answer, and where A and B are the constants and the C is the concentration of the that is in gram equivalent per liter. So, and this constants A and B depends upon the nature of the solvent, temperature and the dielectric constant of the medium, and the values of A are 82.4 by dt 1 by 2 eta, and the value of B will be 8.20 into 10 to the power 5 dt whole 3 by 2. So you have to learn these two values, and D is the dielectric constant of the medium, eta is the coefficient of viscosity of the medium, T is the absolute temperature, and A is the measure of electrophoretic effect, that is our we will study in the detail, and B is the symmetric effect of the water. So water is a solvent here. Then what is this? We have taken temperature T at a 25 degrees centigrade, and our D is the dielectric constant. That value is having 78.5, and eta into 10 to the power 3 will give you 8.95. And at this point they calculated the value of A and B, and A comes to be 60.20 and B comes to be 0.229. So students, if they are asking you what is the Debye-Huckel Onsager equation, you can give this equation, okay. But if we have to derive this equation, it is a bit lengthy, and before starting this equation, as you have seen that here A and B both are representing the measurement of the electrophoretic effect and the relaxation effect. So start its derivation, we have to derive that equation. So I hope we will start first we will study the what is the relaxation effect, what is our electrophoretic effect, and then we will start the derivation. So students, when we in my first video of Debye-Huckel postulates, we have to just read the postulates of our Debye-Huckel theory. What does the Debye-Huckel theory tells that all the electrolytes are completely ionized at all, strong electrolytes are completely ionized at all dilution. The main concept of the Debye-Huckel theory is that we know that if it is a strong electrolyte, their ions are strong completely ionized at any dilutions, okay, and we know that they will create an ionic atmosphere. It means that the positive charge is surrounded by the negative ions and the negative charge is surrounded by the positive ion, okay. So this is the symmetrical ionic atmosphere. Now what does the relaxation effect explains? So for the relaxation effect क्या बोलता है आपका, means like when we saw अभी आपने देखा, just it is a symmetrical ionic atmosphere. What happens when we put this in a solvent and your electrolytes in an electric field, slowly the our positive charge start moving towards the negative charge, okay. So as a result of this, when this positive charge will shift from its place, this symmetrical ionic atmosphere start getting asymmetric, okay, and as a result of this asymmetrical ionic atmosphere is formed. Because this positive charge is moving from its place, means distortion started, and because of this distortion the symmetric ionic atmosphere is distorted, or we can say that it is destroyed. So again, to form a new ionic atmosphere like this, so it will again take the time, means first it is symmetrical, right, first it was symmetrical, then it is got it disturbed, and again we have to form this symmetrical ionic atmosphere. So what is the main relaxation effect? So it will take some time lag, means it will take some time to again form the symmetrical ionic atmosphere. So in the words of the relaxation effect, we will say that the ionic atmosphere distraction will take long time, and the formation of it will take the means what we can say that in the words that the influence of decaying atmosphere on the velocity of ion is known as the relaxation effect. Okay, so what is the definition of relaxation effect? The influence of decaying atmosphere on the velocity of ion. So when the our ionic atmosphere will get disturbed, our velocity of the ions will decrease. In all the cases the velocities of the ions is decreasing, and we will say that there is always a time lag between the formation of a new atmosphere and decaying of old atmosphere. So this time lag, the decay takes place more time, distraction में ज़्यादा time लगेगा than the for new formation. This time interval is known as the relaxation times, and this effect decreases the mobility of ions. So if it comes separately, the relaxation effect, so you can write this notes, and also this what I explained you can take the screenshot of this. Okay, so this is easy for you to define it what we explained, right? Now how we will define the our relaxation effect. So Onsager in 1927 has given the value of this relaxation effect as relaxation effect is equals to epsilon cube zi k into w v by 6 dkt. So what are these terms? So here if you have studied the Poisson's equation earlier, so E or epsilon is our charge, then Zi means if we are considering our ions, means suppose if it is any electrolyte NaCl, Na plus Cl minus, so Z represents the cation or anion, means Z plus and Z minus will represent the numerical values of the two ions, and I will be the valency or the charges, we can say that. And what is our K? K is our coefficient. Here we have taken the frictional coefficient K, or we can and D is your dielectric constant of the medium, and this K is the Debye length. If you have studied the physical significance of K, so this is the Debye length, this is our absolute temperature, and V is the our potential. Okay, so these terms should be clear to you. Okay, so just now we will see our next one, that is our electrophoretic effect. So electrophoretic effect, the molecules, the solvent molecules attached to the ionic atmosphere moves opposite to the direction of the central ion. So to understand this, just we have to consider like we will just say that suppose if our any solvent, suppose we have our solvent as a water, okay, H plus OH minus ions, right? There are a lot of solvent molecules, and we have taken any electrolyte, and electrolyte, if it is a strong electrolyte, it is completely ionized. Okay, so what happens if suppose our solvent is moving towards the, if it is moving towards left side, right, and our this particle is moving, this our strong electrolytes ions are moving towards right side. Okay, so what happens here when it is opposing, there what happens, there is a application of the friction force. Okay, so because of this friction, the speed or the velocity of our ions will get decreased. So what is electrophoretic effect? Electrophoretic effect means they are just our ions are opposing the movement, like they if their solvent is moving in a one direction, then our ions of the electrolytes will oppose that movement and they will try to move, so that their one frictional force will act, and because of that we have to calculate the our electrophoretic effect. So how we can define it? The solvent molecules attached to the ionic atmosphere moves opposite to the direction of the central ion. They cause friction, due to which the mobility of central ion is retarded. So again, both the effect, relaxation effect as well as your electrophoretic effect, the mobility of the ions will be retarded, and this effect is known as electrophoretic effect. So on the basis of the Stokes law, Debye, Huckel give the following expression for the electrophoretic law. So what is this electrophoretic force or electrophoretic effect represent? It is equals to K into V, Ki into E Zi. So again, by 6 pi eta. So here you understand this. This is our Boltzmann constant K, and Ki is the coefficient of frictional resistance of a solvent opposing the motion of the ith kind. Means if suppose our any molecules or our ions, that is Zi we have taken, it is a sum of Z plus Z minus, if they are moving. So here eta is the coefficient of viscosity of the medium, then Ki is our coefficient of frictional resistance of the solvent opposing the motion of the ith kind. So students, to start our derivation for our Debye-Huckel, we should know our both this. Okay, so now let us start our Debye-Huckel Onsager equation. So in the first starting, what we have to Debye-Huckel on the basis of the relaxation effect and the electrophoretic effect, Debye-Huckel had given one simple expression, that is says that W is equals to Z plus Q minus 2Q 1 plus Q1 by 2. And so we will start our derivation of our Debye-Huckel theory, right? So just you can take your pen and paper. So in this equation, the value of our Q is given by, okay, so the value is equals to Z plus Z minus into lambda plus lambda minus. So what is this lambda? We know that lambda is the symbol for the equivalent conductivity of the positive ion, and this is the equivalent conductivity for the negative ion. So by Z plus Z minus, product of the two charge ions, the Z plus lambda minus, now plus is surrounded by the negative and negative is with the positive conductance. So the just you have to learn. So we have to start with W is equals to Z plus Z minus 2Q by 1 plus Q 1 by 2. And so this is the starting of your Debye-Huckel Onsager equation derivation. So the value of Q is given by Z plus Z minus lambda plus lambda minus Z plus Z minus into Z plus lambda minus Z minus lambda plus. So this is equation number 3. So what first and second equation we will take? First and second equation, here we have to take our this one, what is that, relaxation factor, that is equals to epsilon cube, epsilon or E is the charge, okay, charge of the ions, Zi K into WV by 6 dkt, and this is our EF, electrophoretic force, is equals to kV Ki EZi by 6 pi eta. So you can give this as equation number 1 and this value as a equation number 2. We have to use both the factors like our relaxation factor and our electrophoretic factor. So now what they are saying, that when we are talking about what is the force acting on the particular ions, so with the moving with the velocity u, so there should be some driving force due to the applied electric field, and this driving force due to the applied electric field is given by epsilon Zi. So this epsilon is what? Epsilon is the charge. Zi, I told you, this is the charge of our cation and anion, and V is the potential, and they are opposed by this driving force tha ye move kar rahe the, but they are opposed by the frictional force of the solvent, that is Ki Ui, and along with the electrophoretic and the relaxation effect, because both these effect will decrease the speed of the ions. So in simple words we can say that our driving force is equals to, what is driving force? It is our epsilon Ziv will depend upon, or will be the sum of our frictional force of the solvent plus the relaxation effect and plus the electrophoretic effect. ये three आपको starting में चाहिए. So what is our driving force due to the applied field? It is given by epsilon Ziv is equals to, what is your frictional force of the solvent? It is Ki Ui. Ui is the velocity of the ions, okay, and Ki is the frictional coefficient, okay, and also with the electrophoretic and the relaxation effect. So student, just you can write down these terms because they will come again and again. So lambda V is the equivalent conductivity of the solution at a given dilution, lambda infinity equivalent conductivity at a infinite dilution, epsilon is a charge, Z plus Z minus are the positive or the negative ions of the valencies, and we are taking totally as a Zi. Okay, W is the work done. Okay, Zi epsilon is what? It is for an ion, the charge means epsilon represent the charge for any particular ion if it is with the Zi. Then K is our Boltzmann's constant or ionization constant, and our Debye length is our K, where we study the significance of kappa. We are saying it as a, and ui is the our, what is the, it is the frictional velocity here. V is the potential, F we will use, it is a Faraday constant, Ki is the coefficient of the frictional resistance. So now we will proceed to our derivation. So dividing this equation, epsilon z zi v equals to ki ui plus epsilon zi k into kiv by 6 pi eta plus epsilon cube zik wv by 6 dkt. This is equation number 4. So dividing it by kiv and rearranging. So when we will divide it by kiv, so what you have to do, you have to divide the whole equation. Okay, epsilon ziv divided by kiv, then kiui divided by kiv plus epsilon zik into kiv by 6 pi eta divided by kiv plus epsilon cube zik by 6 dkt divided by KIV, इधर आपका WV है. So just you see all this will cancel it, all the V will cancel each other. Okay, KI इधर cancel हो जाएगा. In this KIV whole will cancel out. Here आपका V term will cancel out. So now what you will get? Epsilon Zi Ki equals to Ui by V plus epsilon Zi K by 6 pi eta plus epsilon cube zik by 6 dkt into w by ki. Okay, so here next, by just what we have to do now, we will take all the terms which are present of our epsilon zi terms on the right hand side, we will shift them towards the left hand side. So it will be epsilon zi by ki, this term is plus, so it will be minus epsilon zik 6 pi eta minus epsilon cube zik by 6 dkt into w by ki. You can say it as epsilon also or e. So equals to what is left here, ui v. Okay, now what we have to do, just we will this is in the right hand side now. So what we will do, all these terms we will bring to the left hand side, there is no issue. So what will happen, just the rearranging, you will have uy by v equals to epsilon zi by ki minus epsilon zik by 6 pi eta minus epsilon cube zik w by ki by 6 dkt. So this is equation number 5. So this is very important. So for the maths student, they can directly jump from equation number 4th to equation number 5, but if you want to simplify according to the time, you can go. Okay, so I hope up to here it is clear. So finally you are getting uiv equals to epsilon zi by ki minus epsilon zik 6 pi eta minus epsilon zik w by 6 dkt by ki. Now what they are saying, that this v is the potential gradient and it is taken as in the 1 volt per centimeter. So what they are saying, that in place of v we can put 1 by 300 and multiplying the whole equation by the v. Okay, so when we will multiply the whole equation by v, it will be our like this. Just what we can do, uy by v hai, so I will shift this v to the right numerator here. Okay, we will multiply the whole equation by v. So what it will become, ui equals to v into epsilon zi by ki minus v into epsilon zik by 6 pi eta minus v into epsilon cube zik w by 6 dkt by ki. Okay, so now what happens here, just when we have taken v, so in place of v you have to put our v is equals to 1 by 300. So when you will put v is equals to 1 by 300, so what it will be become like, so we have to put our whole value like this. So in the whole equation you will be having epsilon zi by ki. So either what you have to put, 1 by 300 epsilon zi ki minus 1 by 300, in place of v put 1 by 300. So here also in place of v put 1 by 300, so you will have the same. Now what we have to do, we can take our this common. Okay, so we can take our 1 by 300 common in these terms. So what we will left, epsilon zi by ki minus epsilon zi by zik by 6 pi eta minus epsilon cube zik by 6 dkt into w by ki. Okay, so give it equation number 6. Now what we can do, just we can multiply over this term, first term. So you will have 300, sorry, it will be 1. So epsilon zi by 300 ki minus, just what we have opened the bracket. So what you can take, you can just write them here in both these two terms. This is common na, epsilon k and 300 we have to multiply. So what we can do, we can multiply it with the 300. So what will have, both will have 300 here, 1 by 300. So we can take epsilon k 300 outside, and in the bracket what will be left, zi by 6 pi eta here, and here what will be left, you will have here ये जो आपका epsilon cube है, make it epsilon square and epsilon. So it will be epsilon square and one epsilon we have taken out. So epsilon k we will take out, and it will be, what will be left, epsilon square ziw by 6 dkt into w by ki as it is, right? Now what they are saying that at infinity, what k will be equals to 0, the value of k, because if the length is very much, so जो आपका k है, that is your Debye length, so the value of it will be 0. So whole this term will become our 0. So we have to just what will be left, we will have ui is equals to epsilon zi by 300 ki. Give it equation number 8, right? Up to here it is clear. Okay, so now next you will have what little bit we have to add now, more assumption, that they are saying that lambda I, what is lambda? It is a conductivity or our equivalent conductance at a particular dilation. So for the ith ions is equals to product of f into ui. What is our ui? Ui is the velocity na, so just you have to multiply, it is the Faraday constant. So lambda I is equals to f into ui. So it will be equals to, if we find the value of ui, it will be lambda I by f is equals to ui. Okay, so what they will say that, and one more value is given, that is ui is equals to, what we got at the equation, ui is equals to epsilon zi by 300 ki. Okay, so we have to equate both these terms, right? So just equation number 9, and we have equated. So what it becomes, epsilon zi by 300 ki will be equals to lambda I by f, right? तो ये आपके equal हो गए. Now if we want to, and again one more assumption here what they are saying that ui is equals to lambda I by alpha f. So one more relation here, that is ui if equals to lambda I by alpha f, means again they are taking the degree of dissociation here. Means what was your 9th equation, ui equals to lambda I by f, again here they are saying it can also be this relation. Okay, so we have to substitute this our 10 and 11. Okay, the value of our 10 and 11 equation in our equation number 7. So what is equation number 7? Equation number 7 is our ui is equals to epsilon zi by 300 ki minus ek by 300 into zi by 6 pi eta plus epsilon square ziw by 6 dkt ki. तो इधर आपको ये जो टर्म है यहाँ पे हमको वैल्यू रखना पड़ेगी, and we will just substitute them. So now see how we can substitute. So what is finally, अब इधर ध्यान से देखना है, यहाँ पर आपको what you are getting here. So in the place of ui we will put lambda I by alpha f. Okay, so आप left hand side ध्यान से देखिए, in the 7th equation you have just put here in the place of ui, we will put our lambda I by alpha f, and in the place of your z epsilon zi by 300 ki we will substitute it by lambda I by f, right? And other will remain same. If you are writing, then you will understand easily. Other part our minus epsilon k by 300 into Zi 6 pi eta plus epsilon square. Now this is a time where you can break it into two term. Epsilon square you will write it two time, epsilon by 6 dkt, and one epsilon with you can write with the Zi, like so. We will just open it like this. So what you will have, we will have epsilon dkt into epsilon Ziw by ki. Okay, now what we can do that, when the electrolyte is a completely ionized, and that condition or the degree of dissociation is equals to alpha is equals to 1. So we will put alpha is equals to 1. So this equation again what it will turn like alpha ki value you will put 1, and we have to multiply the numerator by f. So when we will do this step, so just what changes will be taking place, lambda I by f into f. So f will cancel each other, alpha is equals to 1 we have put it. Okay, so it will be lambda I into f by f. So this f also cancels, minus epsilon k into f. So you can see upper equation epsilon k into f by 300 as it is, and the our internal will be same of the equation number 12, right? So just now what we have to do, just in place of our this term, now just what we will do, we will just multiply these terms and open the brackets. So what you will get here, lambda I is equals to lambda I minus epsilon e k by 300, right? अब आपको relate करना पड़ेगा, because what happens here, epsilon के एफ जेड आई ये जो आपका रहेगा ना, आप ब्रैकेट ओपन करेंगे तो जस्ट यू राइट एज इट इज. सो आई हैव रिटन जेड आई हेयर एंड एप्साइलन के एफ because it is f here na, and by 300 6 pi eta plus again this will be a square, epsilon is square Ziw I have written first, and you can take here 6 dkt into epsilon kf by 300 by ki. Okay, so just it is same, just you understand it. And now just you see this in the beginning what we have told, that epsilon zi by 300 ki is equals to lambda I by f. Okay, question number 10 you see. So we will replace our second term this value by lambda I by f. So जब आप इसको replace करेंगे, so what value you will get here, just you see it. So what is the equation, lambda I equals to lambda I minus this first term आपका है ना, उसमें हमने क्या replace करना है, we have to replace zi epsilon 300 by lambda I by f. So it will become your, we will just substitute this value. So this equation putting this value here, and we are reducing it in the form as like. Okay, so what you will get finally, lambda I is equals to lambda I minus ek by 300, and we are taking common from both the terms. So what is common here, in the place of our zi epsilon 300 we are putting what, lambda I by f. So we have taken here common outside. So in this term you have replaced na lambda by f, so it will cancel the f and you will have the reduced form. So it will be equals to lambda I is equals to lambda I minus epsilon k by 300 into zi f by 6 pi eta plus 300 epsilon 3 dkt into lambda I w. So students, this is the reduced what is we have solved now. So now give it equation number 14, and finally by solving this term we will get one equation that is termed as Debye Huckel Onsager equation, and it is represented as lambda v is equals to lambda infinity minus a plus v into lambda infinity square root of c. So by solving this equation number 14 you will have a complete equation, that is your Debye Huckel Onsager equation. So it is no need to solve this in the very much details. आप final equation 15 दे सकते हैं, and where a and b are the constant and they depends upon the solvent nature of the solvent, temperature and the dielectric constant of the medium. And in the beginning I told you the value of a is equals to 82.4, by dt 1 by 2 eta, and the value of b is equals to 8.20 into 10 to the power 5 by dt 3 by 2. So students, this is your Debye-Huckel-Onsager equation. And if you want to continue with the what is the verification of the Debye-Huckel-Onsager equation, so just we can continue with this. That in the starting I told you we got the values of our this Debye-Huckel constant. Just a minute. Okay, so we have these two na. We have the values of a is equals to 60.20 and the value of b comes to be 0.229. So we have just by putting the values, substituting the values of our a and b here, 60.20 plus 0.229 lambda infinity under square root of the c. So we can verify the Onsager equation. Means when we will put these value and we will plot a graph against the lambda v. What is lambda v? It is the equivalent conductivity at a v dilution and equivalent conductivity at infinite dilution. So against lambda v, against our concentration, if we will plot a graph, so you should get a straight line. Okay, so this graph is here. When we are plotting it between the lambda v and the concentration, we should got a straight line. But for the higher concentration, there are the slight deviation. Means if a slight deviation are observed, so finally the Onsager equation respond to this test favorably, and aqueous solution of univalent electrolyte, and it is closely obeyed at concentration up to 2 into 10 to the power 3 equivalent per liter. But अगर हम बहुत high करते हैं concentration, then this will be our deviated, and we can say that if the solution is at infinite dilution, if the dilutions are infinite, so the concentration of the C will be 0. Okay, and then the second term on the right hand side of the equation becomes negligible. Means our this term, second term, this will become negligible, and as b approaches is expected. Okay, so I hope this video is clear to you all. And if they are asking you that directly verification of Onsager, so you can start from this page and you can write what is the Debye-Huckel-Onsager equation, and along with that for the verification, just you have to write the values of all our this terms t and d and our eta, and just you have to plot this graph. I hope the video is clear to you all. Thanks for watching the video, and just comment what topic you want. Thank you. Share my channel with your friends. Thanks for watching. Do subscribe the channel if you have not subscribed.